Okay, so today we're going to be starting statistical inference. We're going to be starting on chapter 12.3 because chapter 12.2 is just stuff for you to read. Okay, so Dylan is interested in finding an average length of television shows on Netflix. He collects 12 samples and records the length of 10 different shows. All times are recorded in minutes. Use the sample means to estimate the mean program length of the population. So all we're going to be doing is calculating the mean for each sample, so adding together all of these numbers in the row. Here, I'll highlight that. Now, the computer is doing its own fun thing today, so we'll just see how this goes. This thing doesn't... Okay, so these numbers are going to all get added together and then divided by how many numbers there are, and that's how we come up with this number here, divided by how many numbers to get that number there. Once you've done that for all 12 items in the sample, you're going to then add together all of your sample means, which is these answer numbers here, 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 and divide it by how many samples there are. There are 12 samples, so we divide it by 12, and that gets you your average sample length of the population. So that's all you have to do for that one. Pretty simple. We're not going to go through it in much detail. The next one we will, though. So the two formulas that you need are these ones over here. Okay, so that is the mean of all of your samples and the standard deviation of all of your samples. So you can see here that they are slightly different formulas to what we're used to. This one's not, but this one is. Now, in your exams for the finals, these two are given to you. All right, so let's start doing the question. 500 students are studying mathematics course at University of the Sunshine Coast. On a recent exam, the mean score was 67.2 and a standard deviation of 17. Let's note that down straight away. So the mean was equal to 67.2 and the standard deviation was equal to 17. Okay, sample sizes of 5. Now, in this sort of question, the sample size is what we call n. Not this number up here. That's more of a fun fact than anything else. So you just kind of get to ignore him. So sample sizes of 5 are selected and the means determined. Calculate the mean and standard deviation of the distribution of x. Okay, so we're going to apply these formulas to what we've got here, where this one is that number, which means that this is equal to that. So the first thing we can do is our expected mean of the samples is going to be 67.2. Now we can calculate the standard deviation. So it's going to be the standard deviation divided by the square root of the number of samples. So 17 divided by the square root of 5, which is this number here, I said, not this one up here. Okay, and that's going to give you an answer of... Now, I stole this answer from the textbook. So these ones haven't been rounded to 4 decimal places. I'm not 100% sure why they haven't rounded to 4 decimal places. I was under the assumption that anything with statistics is 4 decimal places. But, you know, you get what you get. Okay, so your answer for that one is 7.6. So that's A done. Now we're going to do B. Your sample size is increased to 30. Determine the effect that this would have on the mean and the standard deviation of the samples and the distribution of the sample means. So we're going to calculate the mean first. Same thing, didn't change. Okay, your mean is the same as your sample mean. Your standard deviation, though, is going to have an effect because now we'll have 17 divided by the square root of 30 instead of 5. So that is going to reduce your standard deviation to 3.1. Now, it asks you to comment if the sample size is increased to 30, determine the effect this would have on the mean and standard deviation. So we have to comment on it. So no effect on the mean. Standard deviation is reduced when the sample is increased. And Bob's your uncle, that's it.